Hi everyone, welcome to my YouTube channel. Today we're looking at chemistry, May-June 2018, variant 1-2. So let's begin. Now the first question says, a student wants to show that the rate of the reaction between calcium carbonate and dilute hydrochloric acid doubles for every 10 degrees Celsius rise in temperature. The method the student uses is to measure the volume of carbon dioxide released. The student has a Bunsen burner and a gas syringe. What other essential apparatus must the student use? So let's look at A first. Balance, burette. We don't need the burette because we are measuring this experiment using the volume of carbon dioxide released. So this is out. Then we have balance to measure the loss in mass. Measuring cylinder, yes. Clock, so we can see how much gas is collected, and then thermometer to measure the change in temperature. So this looks like the answer. Burette, pipette, no. These burette and pipette are usually used when you're using acids and you're using concentrations and all. So these two are out as well. Which mixture can be separated into its components by adding water, stirring, and filtering? So filtering is a process of filtration. And in filtration, we need to have two solutes, and one out of them has to be soluble in water and the other has to be insoluble. So let's look. Calcium carbonate and sodium chloride. This can be an answer because calcium carbonate is insoluble in water because all carbonates are insoluble in water except potassium, sodium, and ammonium, and sodium chloride is soluble. Magnesium and iron, no, and so A is the answer. Which row gives the correct test to identify both ammonia and sulfur dioxide? So ammonia is an alkaline gas. So alkali, they turn damp red litmus paper blue. They convert red to blue. So they convert the damp red litmus paper to blue. So these are out. And test to identify. Now sulfur dioxide is a very good reducing agent. So since it's a good reducing agent, so I will be adding an oxidizing agent to check for its identity. So C is the answer. Moving on towards question number 4. Two gases, ammonia and hydrogen chloride, at an equal pressure are allowed to enter the apparatus shown. After a time, a white solid forms on the inside of the tube. Which statement explains why a white solid forms in the position shown? Ammonia and hydrogen chloride react to form solid ammonium chloride. Yes, because we're getting HCl gas from here, we're getting NH3 here, they're reacting to form a white solid. Ammonia diffuses faster than hydrogen chloride. Yes, because we can see NH3, which is ammonia, has traveled a greater distance as compared to HCl to form a white solid. Ammonia has a lower relative molecular mass, and the reason why it diffused faster is because it has lower relative molecular mass. If you calculate NH3 mass, you're gonna get 14 plus 3, that's going to give me 17, and for HCl it's going to be 1 plus 35.5, which is going to give me 36.5. So this is lighter than this, and so this is going to diffuse faster. So the answer is 4A. Moving on towards the atomic number of cerium is 58. A cerium 4 plus ion has 140 nucleons in its nucleus. Nucleons, neutrons plus protons. How many protons, neutrons, and electrons are there in one Ce4 plus ion? Okay. The atomic number is going to be the same as proton number, so proton number is going to be 58. So these two are out. Now, how do you find neutrons? So we know the nucleon number is 140, and the proton number is 58. So this difference is going to be 82. So neutrons are going to be 82. And then electrons, since it formed, is 4 plus ion, that means it lost 4 electrons. So 58 minus 4 is going to give me 54, sorry. So it's going to be 5A. Moving on, the diagram shows the arrangement of particles in three solids, X, Y, and Z. The three solids are krypton, potassium, and sodium chloride. Now, we know potassium is a metal, and in metal we have metallic bonding. So this looks like metallic bonding because we have positive ions surrounded by a sea of electrons. So this is potassium. Now, sodium chloride is an ionic salt. Why? Because sodium is Na+, and this is a metal. This is a non-metal. So metals and non-metals, they do ionic bonding. So this looks like a lattice. So it's going to be sodium chloride. So X is going to be sodium chloride. Y is going to be potassium, and Z is going to be krypton. So because this is like a simple molecular structure, so it's going to be 6D. Moving on towards question number 7. Which statement about solid calcium chloride is correct? It conducts electricity? No. Even though this is an ionic substance, but it can only conduct electricity in its aqueous or molten state. You have to remember that because in aqueous and molten state, they have free ions moving around to conduct electricity, but in this we're talking about solid, so we are not gonna get this option as answer. So this is wrong. It has low melting point. No. Most ionic substances have high melting points. This is wrong as well. It has an ionic lattice structure. Yes. It is insoluble in water. No. Ionic substances are usually soluble in water. Ethane C2H6 and ammonia NH3 are covalent compounds. The dot and cross diagram of these compounds are shown. Which statements are correct? A molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. This has 3 hydrogen, this has 1, 2, 3, 4, 5, 6. Yes, this is right. An unreacted nitrogen atom has 5 outer electrons. Yes. In a molecule of ethane, the bond between the carbon atoms is formed by sharing 2 electrons, one from each carbon atom. Yes, because hydrogen only needs 1 electron, while carbon is giving out 2, so it's going to be 2, 2, and like so 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3 as well. So the answer is A. Which statement about the structural bonding of metals is correct? A metal lattice consists of atoms? No, this is wrong. It doesn't consist of atoms, it consists of ions. The structure is somewhat like this, surrounded by a sea of electrons. So these are positive ions. This is wrong. Electrons in a metal move randomly throughout the lattice. Yes, this can be D. Metals are malleable because the particles present are mobile. No, electrons are mobile. This is wrong. The ions in a metal move when positive and negative electrons are attached. No, the electrons move. So this is line B. When one volume of gas R reacts with exactly 5 volumes of oxygen, it forms carbon dioxide and water only. So whenever we are having reactions consisting of gases only, we can take the moles as their volumes. So for example, let's start out with option 1. They're saying 1 volume of gas R. These are the gases. So 1 volume, that means 1 mole of C4H10 reacts with 5 moles of oxygen. It's going to form carbon dioxide plus water. So we're going to be just balancing. It contains 4. We're going to put a 4 here, and then it contains 10 hydrogen, so we're going to put a 10 here. 5 2 10, and 4 2s are 8, and then 5 8. This is wrong, because this is not balancing. I need to have something else here to have equal number of oxygens on both sides, because I have 10 oxygens here, but here I have 4 2s are 8 plus 5, that gives me I think about 13. These are not equal, so this is wrong. Then we have ethane. So for ethane, it's going to be C2H6 plus 5 volumes of oxygen is going to give me carbon dioxide plus water. So basically this, what we're doing, this is combustion. So 5, I have 2 carbon, I'm going to put a 2 here. I'm not going to change 1 and 5 because they have stated in the question that I have 1 mole of gas R and 5 moles of oxygen. So I cannot change that. I need to just balance it, put numbers here so that I can have equal number of all the elements. 2 carbon, and then that gives me 6 hydrogens. I put a 3 here, and so it's 2 twos are oxygens, or 2 twos are 4, plus 3 is going to give me 7, which is, no, I have 10 here, I have 7 here, so they're not equal, so this is not the option. Then I have methane. Methane, if you do it like this, it's not going to be the answer, so it's propane. So let's check. Propane, it's C3H8 plus 5O2, which is going to give me carbon dioxide plus water. So I have 3 carbon, I'm going to put 3 carbons here. I have 8 hydrogen, I'm going to put a 4 here. So now 3 twos are 6, plus 4 is going to give me 10. I have 10 oxygen, I have 10 oxygens, and so these are bad. So it's 10D. Moving on towards question number 11. The relative molecular mass of compound is 166. What is the possible molecular formula of this compound? Okay, pretty simple. So we're going to just measure the molecular masses of all of these. We have C4H3O2. So if I see C4H3O2, we're going to have the atomic mass of carbon is 12. So 12 into 4 is going to be 48. Plus 3 plus the atomic mass of oxygen is 16, so 16 into 2 is going to give me 32. So if I add all of them, I'm going to get 48 plus 35, 8, 9, 10, 11, 12, 13, 7, 83. So this is not the answer. If you do it, like this over for all of them, you're going to see that this is going to be the right option with a molecular mass of 166. Now, a mass of 63 grams of potassium manganate and KMnO4 is needed for the complete oxidation of 23 grams of ethanol C2H5OH under acidic conditions. How many moles of ethanol can be completely oxidized by 1 mole of potassium manganate under these conditions? Okay. So a mass of 63 grams of potassium manganate, KMnO4, is needed for the complete oxidation of 23 grams of ethanol C2H5OH under acidic conditions. How many moles of ethanol can be completely oxidized by 1 mole of potassium manganate under these conditions? So pretty simple. So now, by using the information that they have given, we're going to find the moles of potassium manganate and ethanol. So let's find the MR of KMnO4. So we have the periodic table here. I can see that K is 39 plus, now Mn, manganese. Now Mn is here, so it's going to be 55. 39 plus 55 plus, I can see I have 4 oxygens here, so it's going to be 64. And when I add both all of these, I'm going to get 39 plus 55 plus 64, which is going to give me 158. Now, how do you find moles? Moles is equals to mass over AR. So now mass is giving me 63 grams over AR, which is 158. And when I divide them, 63 divided by 158 is going to give me 0.398. So 0.3987 moles. Right? Moving on, we're going to find the moles of ethanol, C2H5. So first we have to find the molecular mass. Now, C2H5OH. I have carbon 12, so it's going to be 24 plus 5 plus 16 plus 1. When I add all of them, 24 plus 5 plus 16 plus 1, it's going to give me 46. So now let's find the moles of C2H5. So basically we're just using the information that I've given in the question to find the answer. So it's 46 moles is equals to mass over AR. So it's going to be 23 divided by 46, which is going to give me 0.5 moles. Now We know we have KMNO4 and we have C2H5OH. So we just found out moles. We said for 0.398 moles we have 0.5 moles, and they're asking 1 mole of potassium magnate. So 1 mole, how many moles can we oxidize? So we just cross multiply. It's gonna be 0.398x is gonna equal to 0.5, and then I just divide 0.5 divided by 0.398 is gonna give me 1.25, and the closest option I can see is D. Moving on, the diagram shows an electrolysis experiment using inert electrodes. What could liquid Y be? So we can see that this was before electrolysis, and after electrolysis this is the volume of gases that was collected. So this is that one thing, there's one thing that you have to memorize, and that is the ratio of hydrogen to oxygen is always 2:1. Right? So these two gases are produced in this ratio. So it can be seen that this is like 1, this is 2. For example, if I, the double of this is the double of this. So I need to have the liquid Y should be a liquid which is during electrolysis will produce hydrogen and oxygen. Aqueous copper sulfate, no, it's going to produce copper, so it's going to be wrong. Concentrated aqueous nuclear is concentrational dilute sulfuric acid. So when I talk about dilute sulfuric acid, it's going to be H plus, SO2 minus 4, and OH minus are going to be the ions present in this liquid. So obviously this and this are going to get electrolyzed because these two will decompose because OH is way below the activity series than SO2 minus 4, so this is C. It's because it's going to produce hydrogen and oxygen, and because you're seeing this, it is seeing that it's the gases are produced in 2:1. So this was it. Moving on towards question number 14. Magnesium can be produced by the electrolysis of molten magnesium chloride, MgCl2. What are the products formed at the anode and cathode during the electrolysis of molten magnesium chloride? Okay. So it says molten, very important. So when I'm talking about molten magnesium chloride, what are the ions present in magnesium chloride? It's gonna be Mg2 plus and Cl minus. So at the anode, cathode is negative, anode is positive, and cathode, since it's negative, is going to attract the positive ions. Positive is magnesium, so it's going to be this option. The diagram shows a project can be used to extract aluminium from its ore. What are J, K, and L? Okay, so we know these are graphite anodes. Okay, so we know J is graphite anode and anode are positive, so these two options are out. And then we have this electrolyte. So electrolyte is aluminium oxide plus cryolite. We add cryolite as obviously as a solvent and to reduce its melting point as well. So this is the answer. Moving on with question number 16. The reaction is exothermic. So now, when we do this, we're gonna just reduce something, and that is in exothermic reaction, the products have less energy as compared to their reactants. So it can be seen, products are at lower energy than the reactants of these two are, because these two are endothermic reaction. Which diagram shows the correct energy file diagram? So you have to remember this: for activation energy always has to be from the max. If I have, for example, if I have this, so if these are reactant, these are products. Activation energy always has to be from this maximum point to the reactant, so it's always going to be like this. But if it's enthalpy change always has to be from the products and to the reactants. So it's easy to remember that for activation energy, the arrowhead has to be from the top point to the reactant, and then for enthalpy change, the arrowhead has to be from the product to the reactant. So let's see. We have the exothermic reaction, and enthalpy change is negative, so this is out as well. This is left because it has negative and it's from products to reactants. Which fraction of petroleum Crude oil is used as a fuel in aircraft engines. Bitumen, no, because bitumen is used as petrol to like make roads and all. Naphtha, no. Paraffin, kerosene, yes. So this was question number 17. Moving on to question number 18. The equation for photosynthesis is shown. Which statement about photosynthesis is correct? It has negative enthalpy change. Okay, so you have to remember this. Which statement about photosynthesis is correct? It has a negative enthalpy change. The reason why this is not the answer is because there are certain things that you need to remember. Respiration and combustion. Respiration and combustion are exothermic reactions, while the photosynthesis is an endothermic reaction, and endothermic reaction has positive enthalpy change. It is catalyzed by the presence of G. Totally wrong. The products of photosynthesis are oxygen and starch. Oxygen is correct, but this is not starch, this is glucose. So this is wrong as well, so the option left is D. Compound X reacts with an acid to produce sulfur dioxide gas. A sample of X is placed in a flask and acid is added. The sulfur dioxide produced is collected and its volume is measured at various times. A graph of the results are plotted. Which statement about this experiment is correct? The gas can be collected by displacing water from a measuring cylinder. The gas can be collected by displacing water from a measuring cylinder. No, this is not how gas is collected. The mass of the reaction in flask and the constant decrease as the reaction proceeds. Yes. The rate of the reaction increases. No, it decreases. The reaction is still proceeding. Air is going to be somewhere here. It can be seen that the reaction has stopped after 5 minutes. This is wrong as well. So it's B. Which reaction involve oxidation and reduction? Redox reactions. Chlorine gas reacting with aqueous potassium iodide. Cl2 plus Ki, it's gonna give me potassium chloride, because in the periodic table we can see that chlorine is high up than iodine, and so it can easily displace iodine plus I2. So Cl2 starting from 0 and ends up at minus 1. It starts off at minus 1 and ends up at 0. So this is reduced as oxidation. Right. Dilute sulfuric acid reacting with magnesium. H2SO4 plus Mg is going to give me MgSO4 plus hydrogen. So it starts off at 0, ends up at plus 2. It starts off at minus 2, plus 2, ends up at 0. So plus 2 to 0 is reduced, and then okay, so this is an answer. So because plus 2 to 0, it has been reduced. 0 to plus 2 is being oxidized. Dilute hydrochloric acid reacting with aqueous sodium hydroxide. So we have HCl plus sodium hydroxide, NaOH, which is gonna give me NaCl plus water. So it starts off at minus 1, still ends up at minus 1, plus 1, plus 1. This is not the answers, it's only 1 and 2, so it's going to 20B. Now we're going to move on to work 21B. Nitrogen reacts with oxygen at an equilibrium reaction. This is positive, that means it's an endothermic reaction. When the reaction is at equilibrium, which statement is correct? The concentration of nitrogen present will change with time. Now, in equilibrium, in reversible reactions, both reactants and products are present at the same time, and they will remain the same amount throughout the whole reaction. The forward and backward reaction are taking place at the same rate. Yes. The forward reaction releases heat energy. No, it's absorbing energy because the forward reaction is endothermic. There are more molecules on the left hand side of the equation than on the right. Is it all because this is an equilibrium, and that because they have written equilibrium, and that means these are equal. Lead oxide PbO reacts with dilute nitric acid, neutralizing the acid. Lead 2 oxide also reacts with aqueous sodium hydroxide, neutralizing the alkali. That means it is acting as an acid as well as an alkali, so it's gonna be an amphoteric. Which pair of reagents are most suitable for the laboratory preparation of copper 2 chloride? aqueous copper to nitrate and aqueous sodium chloride? No, because copper cannot displace sodium because sodium is, very high up in the reactivity series than copper. Copper and chlorine, make sure you remember that copper cannot react with any acid, in its real form. It has to have an oxide, so it's going to be copper oxide. The compound shown can be used as nitrogen fertilizer. Which compound has the lowest percentage by mass of nitrogen? So how do we do this? We're going to find they have given me NR. I need to find, since they're talking about nitrogen, so I have to see how much nitrogen is there, 28. So it's going to be 28 over 60 into 100. So let's calculate that. We have 2800 divided by 60, which is going to give me 46.7%. Then we have 2800 divided by 132 is going to give me 21%. Then I have 149, and since nitrogen has atomic mass of 14, so 14 into 3, it's going to give me 42. So 4200 divided by 149 is going to give me 28.2%. Then similarly, 2800 divided by 80 is going to give me 35%. So the least and lowest is B. Moving on towards question number 25. The diagram shows 3 steps in the manufacture of sulfuric acid. In which steps is a catalyst used? Catalyst is vanadium pentoxide, which is used in the manufacture of sulfur trioxide. The only step Q. Indium proton number 49 is in group 3 of the periodic table. Antimony proton number 51 is in the group 5 of the periodic table. Which statement comparing indium and antimony is correct? Okay, so let's look at the periodic table. This is indium, this is antimony. So we can see that these are non-metals, and these are non-metals as well, but they are relatively, more stronger metals as compared to these. So we can see that indium has more metallic, because we know transition metals are very good metal, right? So indium has more metallic character than antimony. Let's see what it says here. Indium has more metallic character, yes, so this is wrong. Antimony has more valency electrons per atom because it has greater proton number, so obviously it's going to have more valency electrons, so it's going to be C. The position of 4 elements are shown in the outline of the part of the periodic table. Which element is a solid non-metal? So we know this is aluminium, and this is a very good metal, conductors are wrong. So now it can be 3 of these. So let's see what they represent on the periodic table. So it can be seen that C is chlorine and D is iodine. And then we have oxygen. So oxygen is a gas, chlorine is a non-metal as well, and iodine is a non-metal as well. But it says here solid. It says solid here, so iodine is solid at room temperature. So it's going to be D. 3 elements each show oxidation states of +2 and +3. To which part of the periodic table do these elements belong? Transition elements, because transition metals have variable oxidation states. Moving on to question number 29. Brass is an alloy. Which terminal of brass is correct? It contains CF electrons. It is an alloy. CF electrons, yes, because it is metal. It contains positive and negative ions. It is a compound, not a compound. Brass is an alloy. The alloy are just mixtures, not compounds. So compound are strictly prohibited to use. So it's A, because after all it's a metal. Copper 2 oxide reacts with carbon when heated. Which statement about this reaction is correct? Carbon is the oxidizing agent. If carbon is the oxidizing agent, that means it has to reduce itself to oxidize the other thing. So it started off as 0, ends up as +4, so it's being oxidized. This is wrong. Carbon is the reducing agent. Yes, because it is being oxidized, and that means, when something is being oxidized, that thing is the reducing agent, and when they are being reduced, that is the oxidizing agent. So The diagram shows a cell that can be used to extract a metal from its oxide. Molten aluminium oxide, copper oxide, lead oxide, and magnesium oxide are each electrolyzed in separate cells. Each cell receives the same number of electrons. All the elements can also be extracted from the oxide using coke. No, coke is carbon. So this is wrong because in the reactivity series we have potassium, sodium, calcium, magnesium, aluminium. Till up here, it's gonna be just by electrolysis and not with the help of carbon at all. The anode and cathode should be made of the metal being extracted. Wrong. The pure metal is always produced at the cathode. Yes, because metals, they form positive ions. Take K plus, take Mg2 plus. They form positive ions and cathode is negative, so it has to go move there. So it's C. Moving on towards question 32. Iron is obtained in the blast furnace from ore hematite. Which process takes place in the blast furnace? Calcium carbonate is used to remove acidic impurities. Yes. Now, what do we mean by acidic impurity? We mean SiO2. And the reason why we say it's acidic, it's because it's forming SiO2 and its silicon is a non-metal, and we said acidic oxides are made from non-metal oxides. So this is the answer. Coke is reduced to carbon dioxide. No. Hematite oxide, carbon monoxide. No. No. Aircraft manufacture requires a metal that has relatively low density. Yes. Is resistant to corrosion. Yes. So 33A. It is made from aluminium. Which pair of gases are both non-acidic? Ammonia and methane? Yes, because ammonia is an alkyne gas, methane is not an acidic. Carbon dioxide are highly, I would say, very dangerous gas. Ammonia, no. Methane, nitrogen dioxide, sulfur dioxide, carbon monoxide, all they are poisonous and they're dangerous, so non-acidic. Seawater is desalinated to make it drinkable. What is the main substance removed by desalination? Detergent? No. Desalination, when you want to make something drinkable, that means you're removing salt from it. So sodium chloride is a salt. Moving on towards question number 36. Which diagram shows a branched chain isomer of butane? Okay. So butane has methane, ethane, propane, C4, H2, 4, 8, 9, 10. C4H, because it's an alkane, and alkane has the structure, derivative formula of CnH2 plus 2. So now, branched chain isomer of butane. So now the isomer, it's gonna have 4 carbons and 10 hydrogen, but it's gonna have a different structural formula. So this has 4 carbons. Let's name it. We have the longest carbon chain, methane, ethane, propane. We're gonna name this propane, and then the branched thing is here, the second one. So it's gonna be 2-methyl propane. I'm gonna look for the longest carbon chain. Methane, ethane, butane. It's gonna be simple butane. Longest carbon chain, simple butane. Longest carbon chain, simple butane. So these cannot be the answer because these are just simply written as C4H10. Whereas this, even though this has C4, I will still be writing it as C4H10, but it has a different name. All of these are just butane because they have single carbon chain. So this is A. A straight chain alkene undergoes an addition reaction with bromine. What is the possible structure of the product? Okay, so make sure you remember this. When alkene undergoes addition reaction, for example, if it's going with bromine, Br2, so both atoms of Br are going to fit in the alkene. And if I have C4H8, it's going to be C. Apparently, this is how it is written. This has H, this has H, and then H, 1, 2, okay, so this is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So now when I add bromine, they're going to be, one is going to be placed here, and one is going to be placed here, and so this is going to just remove itself. So it's going to be, let's try making all of these. We have A, it's CH3, CH, H, H, CH, CH, and then they're saying Br, and then they're saying CH2, CH2, and then again CH2, and then again Br. So this is completely wrong because the Br atom, they have to be side by side. It's not like if I place one Br atom here, I'm going to place the other here or here. It's going to be wrong. If I place one here, it has to be with by its side. So this is wrong. And then if I draw B, now B is CH3, CH, Br, CH, Br, CH, 3. So now these two are side by side, so I'm going to be just 37B. Moving on to question number 38. The diagram shows the structure of oxalic acid. So now I can see there are two, they're like dicarboxylic acid because there are two carboxylic acid. That means there have to be two oil. That means for like two OH. So this is wrong. This is wrong because it contains only one OH. It has to have at least two OH. Right, so these two are wrong. Now there contains two carbon, it has to have two carbons, this is C. Some properties of compound G are listed. It reacts with potassium carbonate to produce carbon dioxide. Yes, it reacts with ethanol to produce sweet smelling liquid. It reacts with sodium hydroxide to produce a salt. Okay, so if it's something is reacting with ethanol to produce a sweet smelling liquid, which is an ester, so it has to have it. I think it must be an acid reacting with an alcohol to produce ester. So it is ethanoic acid. Moving on towards last question, which says the diagram shows the formula of nylon. From which compound could nylon be made? So nylon has an amide link. Now amide link means that if I have this, it's gonna be NH2 on one side, NH2 on the other side, COOH, COOH. So when I join these two, it's going to give me a nylon, right? So let's just see, we have CH24, no, this is wrong, CH24, COOH, yes, and then I have CnH2, and this is C. Because this is 2,4, I need 2,6. So 2,4, 2,4, all of the got. So this is the C. So this was it. So if you like my video and it helped you, so please subscribe my channel. Thank you.